Hello everybody, thank you for joining me once again and inviting me back into your homes. We're taking a look at question number 21 on the year 2001 Pascal paper. So question 21, that's the very first question in part C. I know some people just joined for the last 5 questions because they're the really challenging ones. So welcome. Let's take a look at question 21 if you haven't already. Of course, you can always click the link in the description for my videos and you can get a copy of the contest as well as a copy of the solutions if you'd like. It takes you to the Waterloo webpage that has these. So question 21, Cindy leaves school at the same time every day. We're not currently told what time that is. Maybe we'll have to work that out. If she cycles at 20 kilometers an hour, she arrives home at 4:30 in the afternoon. If she cycles at 10 kilometers per hour, she arrives home at 5:15 in the afternoon. At what speed, in kilometers per hour, must she cycle to arrive home at 5 in the afternoon? Okay. Well, I don't know when she leaves, but I think with 20 kilometers at 4:30 and 10 kilometers at 5:15, I think we could probably either work out what time she leaves or exactly how far it is she travels, maybe both. But as it stands, I need to know some piece of extra information to know when she, I think I do need to know both when she leaves and how long in kilometers her distance to home is. Okay. So if I'm going to try this question, I need to try and remember formulas like distance traveled is equal to speed times time. I can rearrange this. This gets me distance if I know speed and time, but I can rearrange this. Speed is just distance divided by time. If I go 10 kilometers in 1 hour, I must be traveling at a speed of 10 kilometers per hour. I can also figure out the time it takes me to go a certain distance at a given speed. The time is distance over speed. They're all rearrangements of the same formula. So as long as you're good at rearranging formulas, you only need to remember one of these. I like to remember it with this triangle right here. It's something I was always taught in physics class. DST. So if I want to figure out distance, I cover it up. And S and T are on the same level. So D, the thing I want, is S times T. If I want speed, I cover up speed, and distance is above time, so speed is distance over time. And using this little triangle again, distance, speed, and time. If I want time, well, when I cover up time, which is what I want, I see distance is above speed, so it's distance divided by speed. So it's a handy little thing to remember. There are a bunch of them in sort of high school level physics classes. The other one that comes to mind is density is mass times volume. Or no, mass is density times volume. So you can get a nice little triangle there. But it's how I remember it. It's a nice visual representation. Anyway, back to the original question. We don't know things like when she leaves. Or let D be the distance she travels to get home. Okay, and I can also, if I wanted to, let T be the time she leaves school. Okay, so what information am I given? So I know if she leaves at capital T and goes till 4:30, it takes till 4:30 at 20 kilometers an hour to travel distance D. So D is speed, which is 20 kilometers per hour, times time. The time is, well, it's 4:30 when she gets there, minus capital T, which is the time she leaves. So what I'm going to do is I'm going to say time she leaves the school in hours after noon. Okay? That way I can say, well, 4:30 is actually 4.5 hours after noon. Because it's kind of hard to do something like 4:30 minus 3:59. That's not the easiest of equations to do. But if I change this to 4.5 and 3 and 59/60ths, suddenly I have fractions I can use. Okay. I also know that she covers the same distance by going 10 kilometers per hour, but she arrives home at 5:15, which is 5 1/4. But she still left school at the same time t. So the time it takes her to travel d is this difference. Okay. So now I can either work out d and t separately, or I think the first thing I'll do is I'll be able to work out d in terms of t or t in terms of d, one of those two. So I can take a look at these equations. I can number them if I want, and I can expand them out. So 1 becomes d is equal to, well, what's 20 times 4/2? If you need to, grab your calculator. 4.5 times 20. So it should be 90 minus 20t. And then 10 times 5/4, or 5.25. That's 52.5 minus 10t. I can set these equal, and I can probably, because they're both equal to d, so I can set these equations equal, and I should be able to find t. 52.5 minus 10t. Okay. So I'll bring this 20t over to this side, and I'll be left with 10t, because 20t minus 10t is 10t. And I'll have 90 minus 52.5 over here. 37.5. So dividing by t, I get 3 3/4, or 3.75, is equal to t. So our protagonist leaves at 3:45. That's helpful to know. Now we could, well, we know what t is. We can substitute back in and figure out what d is. So d is 90 minus 20t. Well, what's t? That's 3 3/4. Which is 75. And that's a total distance of 15 kilometers. Okay. So, she travels 15 kilometers to get home. And she leaves at 3:45 in the afternoon. So what time does Cindy need to leave? Or sorry, what speed does she need to cycle at to arrive home at 5 in the afternoon? So now we're trying to solve for speed. Well, speed, if we recall, is distance over time. Well, in this case, that's going to be 15 kilometers over, what's her time? Well, she wants to arrive home at 5 in the afternoon, and she leaves at 3 3/4 in the afternoon. So we can work that out. 5 minus 3 3/4, that's going to be 1 1/4. So 15 kilometers, 1 1/4 hours. So if you do 15 divided by 1.25, going to be 12 kilometers per hour. So that's the speed she needs to arrive at. Or sorry, the speed she needs to travel at to arrive home at 5 in the afternoon. And there it is, it's D. Okay. So that's question number 21, the very first of the hard questions on the 2001 Pascal. So once again, thank you guys so much for watching, And I'll see you for question number 22 in the next video.